Hello, I'm Amril Mustafa, a Sitecore developer and the creator of Component Studio. Component Studio turns designs into project-aware Sitecore components, including front-end code, templates, GraphQL, serialization, and demo content. Let me show you how it works. Component Studio works in 3 stages. First, it reads the design and identifies the layout, repeated fields, responsive intent, and GraphQL requirements. Second, it adapts the plan using evidence from the target project, including existing components, Tailwind tokens, templates, serialization routes, and query conventions. Third, it validates the code, fields, GraphQL, content, and serialization before writing any files. The model proposes the implementation. The surrounding contract decides what is allowed to ship. Now, let's generate a responsive insights listing from screenshot, including the front-end, Sitecore items, GraphQL support, and 6 demo content items. This is the Component Studio workspace. There are 3 ways to provide a design. You can connect directly to a Figma file using an API token and design URL. You can import a JSON export from Figma, or you can upload a screenshot. For this demonstration, I'll use a screenshot containing a card listing, pagination, and several content fields. The first step is to inspect the screenshot. For vision analysis, I'm using a local Qwen model through Ollama. The image and generation workflow remain on this machine. The vision model is not writing code yet. It converts the screenshot into a structured design description that the generation agent can validate and use later. The analysis is now complete. So let's review what it detected. The design is classified as a listing with a 3-column grid and 6 cards. The analysis also identifies the visible card structure and content fields. Each card contains a title, link, date, category, and image. The cards are repeatable, and the suggested data pattern is dynamic. That means the generated implementation requires a GraphQL query rather than an authored list of Sitecore references. The activity panel records verified execution phases and tool results throughout the workflow. Next, I provide the Sitecore instance serialization route and JSS frontend route. Then I analyze the target project so the agent can understand the solution it is generating for. The analyzer discovers existing front-end components, Sitecore templates, serialization anchors, theme tokens, responsive breakpoints, and GraphQL conventions. This project evidence becomes part of the generation contract. It prevents the model from treating every Sitecore solution as if it had the same structure. The AI connection can use either local Ollama models or a hosted provider. Remote mode supports OpenAI-compatible chat completions endpoints and Anthropic messages endpoints. The model ID, API endpoint, and API key can be configured directly in the portal. For this demonstration, I'm using local Qwen models through Ollama, a coding model for implementation and a vision model for screenshot analysis. The implementation output can be configured for each run. Both generates the front-end, implementation, and Sitecore artifacts. Front-end only generates the React component and optional GraphQL. Sitecore only generates templates, rendering definitions, serialization, and optional content. For this run, I'll generate both sides and enable demo content. Advanced settings allow me to add focused instructions for component behavior, content structure, or project-specific requirements. There's also an optional organization scan. With permission, it can inspect a bounded set of visible Sitecore JSS repositories, identify mature component examples, and build a reusable organization profile. Private repositories require an authorized GitHub token. The token is not stored or passed to the AI model. The organization scan is optional. Project analysis remains the primary source of truth for the current generation target. Now, I'll start the generation. Generation has completed successfully. The result includes the Sitecore serialization artifacts and a front-end implementation. On the Sitecore side, it generated the templates, rendering definition, and 6 demo content items, all ready to push through Sitecore serialization. The React component uses the repeated listing fields identified during vision analysis, follows the project's responsive conventions, and includes pagination. The GraphQL artifact retrieves the same fields used by the component, so the query, TypeScript contract, and rendered cards remain consistent. The files were written only after the complete generated response passed schema validation, semantic validation, and destination collision checks. Now I'll push the generated Sitecore serialization using the standard Sitecore command line interface. The generated templates, rendering item, data source, and demo content use the format and parent anchors discovered during project analysis. The command completes successfully, which means Sitecore has accepted the generated serialization files. The component data source and 6 listing items are now available for authoring. Each item follows the same field contract detected from the screenshot: title, date, category, link, and image. The image fields are intentionally empty because Component Studio does not upload media files or create arbitrary media library items. That remains an explicit authoring step. The important result is consistency. The screenshot analysis, GraphQL query, React component, Sitecore item template, and demo content all use the same fields. This completes the workflow from design to project-aware generation to validated files to standard Sitecore serialization and finally to authourable content in the content management system. That's Component Studio. Thank you for watching.